So let's continue solving inequalities next with this one, number 6, where the inequality is 2x minus 3y greater than 6. As usual, I am not going to write anything, I will just show the graph. So first what we do, you recall, we first replace this inequality with this equality, 2x minus 3y equal to 6, and then we draw the graph of this equality, which will be a straight line, this straight line. To find this straight line, you just say you put x equal to 0 and solve for y. So that way you get y equal to minus 2. So that gives you 1 point on the straight line, 0 comma minus 2. And then you put y equal to 0 and solve for x. That way you get x equal to 3. So you get the other point, 3 comma 0. And the straight line passes through them. And then next what you do, you take the coordinates of the origin, that is x equal to 0 and y equal to 0, and substitute in this inequality. The inequality is not satisfied. That means the half plane containing the origin won't be really the solution, which is the upper half plane here. So that means the lower half plane will be the solution. And the lower half plane, by that I of course mean all the points that lie strictly below this line, not also on the line, because the inequality is strict. So the solution set is the set of all points in the plane which lie below this straight line. Next, number 7, where the inequality is minus 3x plus 2y greater than or equal to minus 6. So this time we do not have strict inequality. So here also we first draw this straight line, minus 3x plus 2y equal to minus 6, which we get out of this inequality by replacing the inequality with the equality sign. And to draw the line, you first, you find those 2 points. So first you put x equal to 0 and solve for y. That way you get y equal to minus 3, and that gives you this point 0 comma minus 3. And then you put y equal to 0 and solve for x, x becomes 2. So this is the other point 2 comma 0, and this is your straight line. And then of course you substitute the coordinates of the origin here in the original inequality. This time this inequality is satisfied, unlike the previous one, because 0 is greater than or equal to minus 6. So that means the half plane containing the origin would be solution. Would be solution means it will be a part of the solution set, because we do not have strict inequality but just this ordinary inequality where there is option for equality. So all the points on the line will also be solutions. So the solution set consists of the points in the upper half plane, that is above this line, including all the points on the line as well. Next, number 8, here the inequality is 3x minus 5y less than 30. So this is strict inequality. So in this case, we need to draw this straight line, 3x minus 5y equal to 30, which would be this. You substitute x equal to 0 and solve for y, you get y equal to minus 6. So 0 comma minus 6 is one of the points. The other point you obtain by putting y equal to 0 and solving for x. So that way you get x equal to 10. So 10 comma 0 is the other point. Alright. And then you substitute the coordinates of the origin in the inequality, 0 and 0. And yes, that is satisfied because 0 is less than 30. So this half plane, the upper half plane which contains the origin, would be the solution set. And this time, unlike the previous one, the points on the line will not be part of the solution set because we have strict inequality. Next, number 9, where the inequality is y less than minus 2. In this case, the equation is y equal to minus 2, and its graph is this horizontal line. It is that line on which every point has the constant y coordinate minus 2. And then again, you just substitute the coordinates of the origin here in this inequality. There is no place for you to substitute x equal to 0, so you just substitute y equal to 0. Is the inequality satisfied? No, 0 is not less than minus 2. So that means the upper half plane which contains the origin is not the solution. So it should be the lower half plane. And also the points on the line are not included. And finally we have number 10 where the inequality is x greater than minus 3. For this one, the line x equal to minus 3 is this vertical line. It is that line on which every point has the constant x coordinate minus 3. You do understand that this distance is minus 3. Distance is not minus 3. The distance is 3, but it's on the left side of the y-axis. So you also note one more thing, that for this type of vertical lines, the line does not divide the plane into upper and lower half plane. There is no upper lower anymore, but rather right half plane and left half plane. But regardless, we just go through the process. So we substitute the coordinates of the origin. Because there is only x available, so you can put x equal to 0. 0 is really greater than minus 3, which means that the half plane containing the origin should be the solution set. So that means the right half plane. Also, since the inequality is strict, so the points on the line are not included in the solution set. Here this exercise set ends. After this, we have the next section where we will solve systems of inequalities, where we will have inequalities involving two variables, but at the same time, more than one inequality will be there. Now, this is what I have thought. Since we are going extremely slowly, because we are seeing everything that is available in the text, so from now on, I won't really show everything. I will show things which are, which are different from one another. Similar things will be left to you. And we won't cover examples that much. We will cover the main part of the theory and we will go straight away to the exercises, and there also we won't solve all the exercises. Many of them will be left to you as homeworks.